Okay, now in last practical we have seen the voltage levels. So we are able to see some numbers like this. At max it should be for 3.3 volts. It should be for maximum voltage it should be 4095. Okay, now here we are having small little bit of problems. First we are going to focus on to convert these levels into voltage, like your voltmeter and your ADC values or voltage value should match. Okay, so we are just designing a small voltmeter. Okay, so let's see what changes we have to do in the code for this. So this is our code. Now, to store the voltage levels, we are going to need one variable. Okay, we are going to need one variable. So let's name it as so uint uint 32 underscore t is equal to voltage, and we are going to name it as millivolt is equal to, initially we are going to store zero value in this. Now we are having this 32 bit of, sorry, 32 bit of data, this 32 bit of data. So for precaution here, what I'm going to do, we are going to make it as 64 because we are going to transmit the ADC value as well as we are going to transmit the voltage levels or data on the serial communication port. So I have made it as 64. Okay, so it will help us to avoid any memory issues later on. Now here we are going to do some small changes. We already have the value of ADC. Now it is to convert this into the voltage. There is a simple formula. So V is equal to, I'm going to write this in the comments. V is equal to ADC. Okay, steps. Okay, so I'm going to write steps. Okay, in means we have the steps we are reading. Okay, so it can be from 0 to 4095. Okay, so in this case the steps we are reading from the ADC is stored in ADC value, divide by the reference voltage, that is V reference. Okay, so in our case the reference voltage is 3.3. If you are using any other controller like PIC microcontroller, this voltage will be 5. Okay, this voltage will be 5. PIC or Arduino controllers. So in that case, this reference voltage will be 5 volt. In our case, the voltage is 3.3. But the voltage we want to measure, it should be in the form of millivolts. It should be in the form of millivolts. So for that, I'm going to use 3.3300. So it is in millivolts, reference voltage in millivolts. Okay, so here, sorry, it is multiplied by, so input steps multiplied by reference voltage divide by biggest possible step. Okay, so this step is counted from the resolution. The in our case the resolution is 2 raised to 12. Okay, and minus 1. So 2 raised to 12 is your 4096 and minus 1. So the maximum biggest step is 4095. That is what we have seen recently in our simulation. Okay, so we have to implement this formula. This is max step. Done. Now here what we are going to do, simply we are going to implement it according to the comments. So voltage, that is in millivolts. What is the program? Okay, sorry, we're having a typing mistake over here. So voltage in millivolts is equal to input steps. So input steps are stored in ADC value multiplied by 3300, that is 3300 millivolts. You can, if you want answer in voltage form, so you can write 3.3 volts also. I am taking millivolts, there is a reason, I'll explain that later on. Now after this, divide by biggest step, that is 4095. I am using U intentionally, so it will be unsigned. There is no confusion regarding to the sign. It will be always in unsigned manner, means it will be always in positive side. Okay, so our conversion has been done. Now what what is left? I have to send this data over the UART. I want to transmit this data over UART. So I'm going to copy this. I'm going to paste it over here. Okay. So to keep in mind that we have already increased the size of the buffer. Now this line, especially this percent %lu, is going to print ADC value. Similarly, we want something for our voltage also. So here voltage slash r slash n. Okay. So again here also we are going to use percent %lu, that is long unsigned. Okay. You can use int. You cannot use int because it will be in decimal point. Okay. So this part is complete right now. Okay. There is no further changes. So let's build it. Okay. No errors, no warnings. Let's get back to the Proteus. Let's try to run this. Okay, we are getting some voltage. Okay, there might be some issue. Okay, now you can observe one problem here. Okay, so here it is mentioning 5 volts. If I reduce the voltage a little bit, the problem is that here you can see 3.3200 millivolts, that is 3.2 volts. So these values are not matching. Okay, this issue is due to the settings of Proteus. I'm going to stop the simulation. Here in design you have to go to the configure power rails. Okay, this is an important setting for STM32 only. Okay, here you have to configure VCC VDD, that is power. So this is the reference voltage. So we have to make it 3.3 volts, as well as what we are going to do, this maximum is should be 3.3. Okay, let's run this now. Now our voltage is 3.20. Here also we are getting the same. Okay, so we have designed one small voltmeter. You can see that the value of this and this is completely matching. Okay, 2.838 and here 2.84. So this is how you can design the voltmeter. Now using this you can also measure the AC voltage. Okay, but instead of pot you have to use a precise proper voltage divider. Okay, there is no not much more complex circuit in the your multimeters. If you open your multimeter, there are, you can see the voltage dividers are there. Okay, so this is your voltmeter based on your STM32. Okay, if you want the answer in volts, we are going to do little bit changes in the code. So let's make it 3.3. Let's check whether it is going to work or not. Okay, no issues, no errors. Let's play. So it is providing 2 volt, 3 volt. So you can do this in the voltage also, no issues. Okay, so stop here, this here. Okay, and if you want to do, the answer should be in point also, available in the points also. So you have to make mention this as float. Okay, so it is going to provide you 2.3 volts, 2.4 volts, 3.3 volts, like this. Okay, so this part is done. Now what we are going to do, we're going to make it as it was previously. Okay, now we have successfully read the voltage levels and we have transmitted it over your UART. So we have done this in the coding session as well as in Proteus session. Now we have to do this same in the hardware, in the actual hardware. So we are going to see that in next session.